Hello, folks. I'm Matthew Barr. I actually am technical architect at Snap Interactive. I lead the ops team for the most part. We make a Facebook app, AYI, it's an iPhone and Android, AYI. Got 5 billion users, etc., etc., whatever. I'm a member of LAMSA, blah, blah, blah. You can find me mostly on GitHub and Twitter at Matthew Barr, or my email address. So, continuous integration. Who knows what continuous integration is? We've heard a couple people mention it, especially Paul's talk just now. Everyone, not so much. Okay, so it's the practice of frequently integrating one's new or changed code with existing code repository. We've got a couple of major elements. One, maintaining a code repository. Automating the build, making the build self-tested, keeping the build fast, and the fact that everyone can see the build. I'm pretty sure I grabbed this from the Wikipedia definition because I thought that might be a nice, easy medium point. So, Puppet. Everyone knows what Puppet is, right? If you are the Puppet camp. Okay, Jenkins. So some folks probably haven't heard of Jenkins. Jenkins is a CI tool. It's really mostly a tool that can just, on command, do something that you define. Typically things are done in jobs, and that's where you get the build and things along those lines. So this is kind of what the interface looks like. Another popular one is Travis CI. That's more of an online one. There are a couple others as well. So let's do this. We're going to cover, setup, some static analysis tools, module testing, catalog testing, dynamic analysis tools, and nightly rebuilds, as well as actual deployment with Canary servers and production rollouts. So setup. So first of all, has everyone? Well, you guys all didn't necessarily know what. Some of you aren't actually Puppet users that far yet. So there's something in Puppet where I think Adrian wrote a blog post on dynamic environments. So if you Google Puppet dynamic environments, you'll actually get this page. You should look into it. It's helpful. Now, who is using source control with their Puppet code? I'm going to rephrase that. Who isn't using source control with their Puppet code? Thank God. Okay. This fits into the some of the Git workflow. There are others. If you're using Mercurial or something along those lines, I'm sure it will work, or Perforce, I'm sure it will work. It will probably even somewhat work with SVN, but ooh, it could be painful. Git basically is a really cheap way to go ahead and each branch is cheap, so it really helps go ahead and make branching often. So what that Puppet Dynamic Environments allows you to do is to go ahead and have each branch be its own environment. Just like Paul was talking about before, where you can go ahead and set the environment on the system. You're really going to want to, you're going to go ahead and specify on the command line Puppet agent -key, -- environment, and then the name. That's going to let you go ahead and actually test on any particular system you have, be it dev or something else, that new code branch that you're bringing in and testing. So, I'm really glossing over some of this, but for installing Jenkins, there is actually a Forge module for installing Jenkins. Unfortunately, it was written by R. Tyler Crow, and it's a little out of date on the Forge. The branch on GitHub is far better. It's on my GitHub or his. We've added slave. I wrote a bunch of the code for the slave mod, slave setup, things along those lines. It actually allows you to dynamically add slaves to the Jenkins system so you can have more servers and things like that. I'm going to go ahead and actually release most of what I'm showing today into a module, probably. I have to figure out how best to do that. So it probably won't be as painful to set up. Those slides will be available later. That's what we got. So this is what Jenkins can look like. I've just set up a Puppet CI meta job. Actually, this is called a multi-job. And so you can see, how well can you guys see in the back? Sorry, the projectors are only so big, guys. You might want to move closer if there's a lot of space up front. If you can't read this, oh boy, it's going to be a long day. What you're seeing here, so I'll do a little bit more description than I might have otherwise. What you're seeing here is the pointer. What you're seeing is the job name up top, and then each phase is implemented and run separately. So if it fails, then it'll stop. It fails early and fails are cheap. So the first thing we do is static analysis tools. Then we go into the compile tests, and then we go into the dynamic analysis tools. Each job in the dynamic analysis area runs at the same time, but it allows you to go ahead and test things in order. So, folks have heard of GitHub?
Yes.
Okay. One of the things that GitHub really allows for is pull requests. People familiar with this concept? And people have been looking, working with open source products. The vast majority of them these days are starting to use GitHub. So pull requests really allow you to do some things that are really nifty that aren't really inherent in Git, but really make life nice. As in Jenkins, there's a module called GitHub Pull Request Builder, which basically monitors GitHub for a pull request, triggers a Jenkins build, and then updates the merge status on GitHub. So what that looks like is something like this. So this is the pull request I typed in that I wanted to go ahead and update the pull request builder config file. That's the, typically it's going to be off your commit messages. You can see where it says good to merge. That actually is being updated by Jenkins box in our data center, going back up to them. There's an API for that. You can see over there the commit at the very end is actually marked as good. So as you add more commits, it checks each commit that's been added to the pull request after it was opened. It actually checks the merge on the final merge of this branch into master or whatever you specify. So it does actually go ahead and achieve. It doesn't test the branch, it tests the actual merge, which allows you to find a merge conflict or things like that, which is actually nice. And then down here, it actually lets you say that it'll tell you that it's good to merge, and then it'll actually do the merge for you, instead of having to do it on the command line. So, static analysis. Everyone should probably be doing a good portion of these, even on your local laptops or workstations. Most of these can be added in as Git commit hooks. So every time you commit something, you should be probably executing most of these. Static analysis is things that happen on the code without executing the code. So in this case, we're talking about Puppet Parser, syntax checks, and then ERB syntax checks. And then Puppet linking is really for style guide violations. You can actually implement those into hooks. If you just Google Puppet Git hooks, I'm pretty sure I didn't actually link it, but there are a bunch of people that have done this. It's very easy. It's just a simple script that goes into your Git config on the repo, and that will prevent you from committing problems. It catches things like this. Now, I'm going to bet, based on prior experience, that some of y'all back there can't read this. Sorry. So what this is actually a Vim syntax markup of a very basic class. You can see that, well, for the people that are close enough, there's two errors I can see right away. And the fact that the colors are the way they are actually kind of give it away. But that's not a bad thing. In fact, I'll probably go ahead and put up some of the Vim environment stuff that I use, as well as I actually also use TextMate, but and I need to go ahead and publish out the current TextMate 2 Puppet Parser and syntax module. But as you guys can see, there's only one set of quotes on the content line on the template, which is why the rest of the line is red. And that is why you're getting an error immediately. I tried to commit it. Or if I tried to commit it, it would have said there's an error syntax error needs a second quote, basically. What you can see below that is actually a public linked output. This doesn't follow the style guide particularly well at all. It's got tab characters. It's got trailing white space. And the places that aren't tabs use actual spaces, but they're not two spaces, and the actual, I don't know what to call them, it's not rocket ship, but the arrow, the setting things are not aligned either, which is a violation of the style guide. So, that's pretty much it on the static side. There is as well module testing, which Paul did a wonderful job on. I'm not going to try and go into that. It's RSpec Puppet. There was Puppet Cucumber or Cucumber Puppet, but that was discontinued. And screenshot a picture. So it works really well for advanced testing of single modules and complex logic, HIRA, things along those lines. If you're in a really tiny environment or a single OS, single type environment, as he said, if you go ahead and put too much information in, you're basically going ahead and actually duplicating the module. So you want to try and make it so it's an interesting test, a useful test, not a full duplication of the actual code. Catalog testing. So this is one way to do it. There are other ways. And someone just mentioned that there was, in fact, a gem that also helps do this as well. But one of the things you can go ahead and do after you've decided that the code is good from a syntactic perspective, you need to go ahead and go past that to what will happen, does it actually compile into a catalog? Does everyone know what the Puppet catalog is? You heard multiple people talking about it earlier. Basically, it's what is generated. The Puppet agent sends a bunch of facts up to the master. Master compiles it and combines it with the actual code that's in the specific environment that it's using, and all the things that are available to it, and then generates a catalog. And that's what's shipped back to the client. Client applies it, then sends a report back with what happened. Well, if you can't compile it, it doesn't help. So you might as well find out that you've actually messed up before you go ahead and get to the stage of deploying it. So that's just silly to waste time. So here's one way to do it on the master. You can do this. It's probably not the best way, but it is a way. There is OHEAD Levy's Manitest does it as well. It's a little different. I think there's also a Gem Puppet catalog. What?
Server spec as well.
Server spec as well. Well, later on, people will tell me I'll add updates to this thing, or we'll actually get to the some other things as well. So this is just a quick way of doing it, just a quick bash script that basically goes out and makes sure to update the code from GitHub based on a branch, and then goes ahead and tests against that for two different types of servers. Basically, it is to go ahead and test your critical systems or your types, so you make sure that the code compiles across all of them. Yeah, it's kind of like RSpec on some levels, but it's not. It doesn't really help that way. Okay. Now, what does catalog testing catch? It catches dependency loops, and then modules, variables, or facts. Things where you're declaring something should have been there, but isn't, and therefore the whole system breaks. This will help you move when you move from, say, a web server. You've added a package, you've added a module, or something along those lines, or a class. You're calling a class that doesn't exist. For example, you can see I had gone into our common module and added class ABC. Include ABC. Well, it won't catch. A syntax check won't catch that. So this does, and it caught it before you actually deployed it. Which you misspell something, a class name or something along those lines. This would catch that. Dynamic analysis. So this is where you get into actually running the code. See what happens. It's the only way to really see what's going to happen when you do it. But it can have its downsides because you actually have to run the code. So it is possible to break your test systems when you do this, if you sufficiently mess up. I've done it before. That's why they're test systems. You should be able to re-provision them or fix them very quickly. VMs are great for this, by the way. So, basically, you really want to do a test as much as you can. Ideally, you test deployments to all types of servers per environment, and then see what happens. Basically, mocking the production area so that you can make sure that it won't break when you go to prod. You also want to know what kind of changes are going to happen if you were to run this in prod. It'll also help you catch things like RPMs, which aren't in a repo, if someone's messed that up, or if there's a dependency problem in the RPM itself, as opposed to, say, the actual manifest. I assume this happens with Debian as well. I don't actually use it right now, so I'm sure that it's possible to break things just by not having your repos correct, things along those lines. As well, integration tests, which catch config files that might break a service. What happens if you put something into an Apache file and it just doesn't pass the Apache syntax check? Apache won't start up. Well, at that point, you've basically got a change that's gone out that will take your entire site down if you're running a web server, a web farm. And you wouldn't know about it until it got out to prod. It looked fine, seemed fine, but you're not testing it. So this is why you need to go ahead and go that next step and actually test deploying that actual file into prod, into an area as close to prod as possible, and make sure it actually will work. So what I did was just implement Jenkins, basically a simple SSH out of Jenkins onto a test host, which does an agent apply. And you can actually see the output below. This is another log parser module in Jenkins. But blue is pretty much okay, that's just info. Red is errors. And basically in this case, the repos, the package being required wasn't actually in the repo, and it causes a problem. This server wouldn't work. It won't serve the site, it doesn't have all the required packages, and that would be bad. Well, in order to do that, it required a small parser plugin, parsing rules file. So pretty much just a short thing that defined it, not very complicated. It's in the docs for the log parser. How am I doing? I'm going really fast. How's everyone doing today? So, integration testing. Folks have heard of it? It is to cover critical functionality. I know, it kind of says on the slide. So, really, you want to go ahead and test the things that matter. Now, for us, that may be as simple as just doing a curl. The point is to know that curl still works, the site still returns what it's supposed to. You might have something a lot more complex. Now, one thing you could do here is use Nagios checks, guys. Nagios checks work great. They have success and failure. Jenkins basically takes anything that will return a 0 as success, a 1 as a failure, or actually anything other than 1, anything other than 0 as a failure. That allows you to pretty much do anything you want. You can use a sequence of Jenkins commands, shell commands, to do things. So you could have, in this case, if it was a web server, you could go ahead and test that it brings up Apache, that it has everything's working correctly, you get the right result off of the actual web server, possibly including making sure that it can still talk to the MySQL server and then the Mongo server, and maybe Solr at the same time, and Memcache. You might also have a separate set of tests, another job, that actually checks the MySQL box to make sure that MySQL is still running, and that things like it has the right databases installed on it, depending on your deployment levels and what you're actually pushing, you may need to do that if you have the possibility of overriding your MySQL databases. Maybe slave lag, replication, things along those lines. So, now, the next step after all of this is what happens when you have systems bit rotten, right? Every machine, we provision new servers all the time. But what happens if you don't provision a new server in the last month? And well, Red Hat came out with 6.4, and there's some updates to this, and well, CentOS, you're using a couple of systems that are CentOS based, and well, OpenSSL requires a new version, but the i386 version of the package isn't compatible, hasn't been released, and haven't updated it in your repo. And you find out that you can't actually build a system that works from scratch. Yeah. Oh, right. And you promised that you've been able to give an SLA to go ahead and deliver new systems in about 10 minutes. Right. So if you don't build and test your builds fairly often, you're not going to know. So I'm pretty much recommending that folks build their systems, each type of system they need, fairly often. Doesn't have to be nightly, but you need to go ahead and rebuild them from scratch often. Sometimes people go ahead and accidentally remove a line they don't think is necessary, a package that no longer is necessary, they think, and goes in, Puppet change is no problem. They're not doing an ensure removed. I'm sure absent, I mean, and so it's fine. It doesn't take the package away, it's just no longer managed. I've actually seen systems that will go ahead and work on the existing system because it had that package that was added, but the dependency is no longer there. It's not actually tracked in the RPM, but it still works. For example, Jenkins does not actually require Java in its RPM. It kind of requires Java, I promise. It's a Java app. If you don't have Java installed on the machine, it isn't going to work. But if you try to build a new Jenkins box, it still won't work if you lose the line that has the package Java, or a package open Java open JDK 1.7, whatever it is. So if you don't do this, you can't be sure you can rebuild systems, you can't add new ones. Only you can prevent bit rot. So when we started doing this work, I tried to use the Puppet Cloud Provisioner for VMware and found that it didn't particularly like Puppet 3, I think. And so I kind of ended up implementing something similar on my own. So this is just a quick fog script. I don't know if fog.io, people have heard of it, but it's a library that goes ahead and abstracts out cloud provisioning tools as well as including VMware. So this basically brings up a VM, clones a VM that exists, a template, talks to Cobbler, adds an IP, adds the HCP, which also goes ahead and adds it into IPA, which is our Kerberos management system, and then powers on the machine after that. Now, the trick is, if you're going to rebuild the machines every night, you also have to make sure to clean them up before so that Puppet doesn't get cranky because the SSL certs have changed. So you need to remember to clean up your toys. So we destroy the VM, we remove it from Cobbler, and then we remove it from IPA, and then this also should actually say removed from Puppet as well, which I just realized it doesn't. The code does. Have folks heard of Canaries servers? Everyone know what I'm talking about. Canaries in the coal mine. I don't know if you guys can read the little one. The little canary in the bird cage says, "It's getting dark, cold, goodbye, cruel world. It's a poor, unfortunate soul, but it lived for our good." So, the idea is that if you try a system change on one server and it breaks, you will hopefully be able to catch it before it takes the entire site down, the entire service down. So we go ahead and test. This is more just commentary. We haven't necessarily gone ahead and implemented this automatically because this is an action we want to go ahead and make we only have a very small ops team, so for right now, we're doing it manually. But we will be integrating a dashboard for doing this kind of work soon, which will run a separate Jenkins job that will not be connected with the actual continuing deployment, continual integration. It'll just be like an actual separate deploy job. But we can actually go ahead and just basically test the environment, we merge the pull request, and then functional checks happen. We have Selenium jobs for the site, things on those lines. And then your monitoring tools run. One thing I have noticed is there's very little conversation about this. I just tossed up a quick discuss Google group in case anyone wants to actually continue talking about this kind of work with Puppet. I looked at Puppet CI and found that it was actually kind of already in use by Puppet Labs for their Jenkins server, running all the RSpec jobs, and couldn't really use it. I actually do have a module that brings up a Jenkins server and sets up all the static analysis tools automatically, including all the various jobs and things on those lines. If people want it, I'm going to work on getting it into a release state. I might even be able to make it into a Puppet Forge module, but we'll see how well that works. And that's pretty much what I've got. You can find me on GitHub and Twitter at Matthew Barr. It's 2 R's. The program actually has it as 1. It's really 2, I promise. I've been using it all my life. And that's pretty much where I was. And I meant to leave that on. So, anyone have any questions? And
More of a comment than a question.
Sure.
But we're actually doing pretty much everything that you just described.
Okay.
And it is somewhat surprising to us that there isn't more of this going on. And our implementation looks very similar to yours. But I just want to toss out an alternative that people might consider. We use Vagrant VMs.
I meant to mention Vagrant because I'd forgotten to bring it up because this was on the farther end of this. But if you're not using, who knows what Vagrant is? Okay, not everyone's raised their hands. If you're doing Puppet development and you're not using Vagrant, you really need to be. It's really helpful. I actually think I have on my GitHub one of the repos is my Vagrant build, which allows for, I actually bring up a VM, 2 VMs in VirtualBox. There's now possibility for Mac, for VMware Fusion as well, but it's I think paid. But I bring up a Puppet master that automatically comes up all the way, and then I actually bring up a client which doesn't actually run Puppet so that I can actually manage and test it as I want to. Something like that. Is that what you guys are using?
Yeah. More or less.
There are other ways to do this. You can test. My laptop only has 4 gigs of RAM that I couldn't run enough to actually do a Puppet master, a Jenkins server, and slaves all at the same time. I ran out of RAM. That was a problem. Oh, by the way, this is the naive version implementation, some of these ways of testing these kinds of tools. This was really more about what kinds of things people should be testing, not necessarily the best way to necessarily do it. So that's something to consider. I'm happy to accept and compile changes and try to go ahead and keep. There's very little information out there as to the best way to test things and the best way to use Puppet inside of continuous integration environments. Very little has been published right now. It's a really new area, and people just aren't talking about it. One of the areas I've noticed really is lacking is there really is not a good unit test framework for systems level checks. You can't. There's something like an RSpec for systems. It just doesn't exist.
There's a recent project called ServerSpec, which starts on that, and there's some Puppet integrations, and there's a couple of people working on tools around that, integrating a Puppet and stuff.
Right.
And Ken Barber, who works for us as well, just released a product called RSpec System, which is essentially the way to use RSpec to test systems. Thoroughly recommend it. It's really cool. He's demoed some of it for me. It's worth looking at.
Like I said, there's not very much communication going on right now about all this.
We only released 2 days ago, so.
Well, when I look 2 weeks ago there wasn't one. I thought it would be a great idea. Yeah. I really would like to go ahead and have there be more talking about this and more openness. There's no reason we need to keep this all siloed. There's no downside to anyone. No one really, this is not business critical work. It isn't your internal company's designs as to how they run their code base, their transaction processing, or anything else. We're all out here to help. This is the kind of stuff we can do and we can share. Anybody else? Okay, silence, crickets.
Excellent. Thank you, Matthew.
Go back.